Hello grade 10 learners! Handa na ba kayong matuto with our today's lesson? Kaya i-ready na ang inyong pen, notebook at self-learning modules to take note the important concepts. At this juncture, let's continue our discussion in proving theorems related to chords, arcs, central angles, and inscribed angles. Yours truly, Ma'am Marian B. Milianes. At the end of the lesson, you need to prove theorems related to chords, arcs, central angles, and inscribed angles. You can use the concepts being discussed on the part 1 related to this video lesson. Don't also forget to like and comment to the comment section below. What are you waiting for? Let's start! Let's start with the theorems related to central angles and their corresponding arcs. The first one, in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. For example, here we have circle E and circle A. Given, circle E is congruent to circle A. Angle KEY is congruent to angle CAR. Let's prove that arc KY is congruent to arc CR. To prove the theorem, let's use two-column proof. On the left column, we will write our statements, and our reasons will be written on the right column. So let's start proving with our givens. Number 1, circle E is congruent to circle A, and angle KEY is congruent to angle CAR. The reason for that is given. Since angle KEY is congruent to angle CAR, then we can say that the measure of angle KEY is equal to the measure of angle CAR. We use here the definition of congruence, in which if the two angles are congruent, then they have equal measures. Look again at the figure. In circle E, angle KEY intercepts arc KY, and in circle A, angle CAR intercepts arc CR. So the measure of angle KEY is equal to the measure of arc KY. And the measure of angle CAR is equal to the measure of arc CR. The reason for this is the degree measure of a minor arc is the measure of the central angle which intercepts the arc. In number 2 statement, the measure of angle KEY is equal to the measure of angle CAR. But these two central angles are also equal to the measure of their intercepted arcs. So in number 4, we can say that the measure of arc KY is equal to the measure of arc CR. We use substitution property in relation to the number 2 statements. And lastly, we can say that arc KY is congruent to arc CR, because the measure of arc KY and the measure of arc CR are equal, then they are also congruence. The reason is the definition of congruence. Next theorems are the theorems related to chords and their corresponding arcs and a chord perpendicular to a diameter. Number 2, in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. In this example, we have circle D and circle A. Given, circle A is congruent to circle D. Chord MC is congruent to chord PR. Let us prove that arc MC is congruent to arc PR. Let's have the two-column proof. Let us always begin with our given. Number 1, circle A is congruent to circle D, and chord MC is congruent to chord PR. The reason is given. Let us draw segment DM, segment DC, segment AP, and segment AR. Here, since the two triangles are congruent, segment DM is congruent to segment DC, is congruent to segment AP, and also congruent to segment AR. What's the reason for this? Remember, the two circles, which are circle A and circle D, are congruent. Now, we can say that the reason for this is that all radii of congruent circles are congruent. By drawing segment DM, DC, AP, and AR, we have two triangles in both circles. Segment MD is congruent to segment AP. Segment DC is congruent to segment AR. And segment MC is congruent to segment PR. Therefore, we can say that triangle MDC is congruent to triangle PAR. For what reason? Remember, if three corresponding sides of two triangles are congruent, we can also say that the two triangles are congruent. The reason is the SSS postulate, or the side-side-side postulate triangle congruence. Since the two triangles formed are congruent, we can say that angle MDC is congruent to angle PAR. The reason for this is congruent parts of congruent triangles are also congruent, known also as CPCTC. Now, we can prove that arc MC is congruent to arc PR. What will be our reason? We can now use theorem number 1. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Another theorems related to chords and their corresponding arcs and a chord perpendicular to a diameter is this. In a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. In this example, we have circle N. Given, segment AR is perpendicular to segment MI at N. Let us prove that segment AR bisects segment MI, and at the same time, segments AR bisects arc MI. Let us now prove the theorem using again the two-column proof. Number 1, segment AR is perpendicular to segment MI at N. The reason is given. Let us draw now the die EI and EM. The reason is by construction and definition of radius. Remember, radius is a segment formed from the center of a circle and a point on the circle. The third statement is segment EM is congruent to segment EI. The reason, radii of the same circle are congruent. Number 4, segment EN is congruent to segment EN. The segment is equal to itself. Therefore, the reason for this is reflexive property. Since segment AR is perpendicular to segment MI, we can say that angle ENM and angle ENI are right angles. This is the definition of perpendicularity. When two segments are perpendicular, there are right angles formed. A while ago, we drew segment EM and EI, and we formed two triangles. Since there are right angles in your given triangles, we can say also that triangle ENM and triangle ENI are right triangles. Why? The reason is the definition of right triangles. In a right triangle, we have at least one right angle. Number 7, triangle ENM is congruent to triangle ENI. What is the reason? We use here HL congruence postulate. In a right triangle, if two triangles have congruent hypotenuse and one of their legs, then the two triangles are also congruent. Number 8, segment NM is congruent to segment NI. Since we have two triangles that are congruent, then all corresponding parts of the congruent triangles are congruent. So we can reason out in number 8, CP, CTC. Number 9, segment AR bisects segment MI. The reason is the definition of segment bisector. AR became the segment bisector of segment MI, and it was divided into two congruent parts, segment NM and segment NI, which is shown in statement number 8. Number 10. By CP-CTC, we can add also the statement that angle MEN is congruent to angle IEN, because congruent parts of congruent triangles are congruent. Angle MEN intercepts arc MR, and angle IEN intercepts arc RI. So, arc MR is congruent to arc RI. For what reason? Congruent central angles intercept congruent arcs. Finally, we can now prove that segment AR bisects arc MI. And the reason for this is definition of arc bisector. Dear students, continue watching the video next to this. God bless.